Today we're going to be looking at the last of the forms of the quadratic functions that we're going to look at this year. Today it's called factored form, and the reason for that name isn't going to be entirely clear until we do the next unit. However, I think that the rule is easy to understand. So if you take an input this time, we're going to do two different things to it. We're going to subtract 5 from it, and we're going to subtract 3 from it. Then we're going to multiply those two numbers together. Then we're going to take that result and multiply it by 2. So let's follow this through with a couple of examples. So if we had an x and we had a y, take our x, let's say we use the number 3. Okay, so that's going to be our input. So now we subtract 5, so that's going to be minus 2. And we subtract 3, well that's 0. Multiply those two numbers together will give us 0. And multiply by 2 will also give us 0. So when we plug in a 3, we get out a 0. So like we did before, let's just kind of get our heads wrapped around this by doing a couple more. So let's do 2. So plug a 2 in, subtract 5, you get minus 3. Subtract 3, you get minus 1. Minus 3 times minus 1 is plus 3. And plus 3 times 2 is 6. So we get a 2 gives us a 6. And we could keep going. What I would like to do instead, though, is kind of summarize this in an equation so that we could use the equation instead to come up with our inputs and outputs, just because equations are just a little bit easier to work with. So our output is equal to the number that we start with. Okay, so that's x, that's our input, take away 5. Okay, then we do the same thing, x minus 3, and we multiply the two together. So that's how we represent that. And then we take that result and we multiply it by 2. And that's what we get for our equation. And then we're going to try to work with that. Okay, so let's plug in some numbers. So we're going to take 1 away from there, or 1 minus 3 is minus 2. 1 minus 5 is minus 4. Minus 2 times minus 4 is going to be plus 8, times 2 is going to be plus 16. Okay, and again, I'm just going to work here and just do it quickly here. So we'll do this one again. 2 minus 3 is minus 1. 2 minus 5 is minus 3. Minus 3 times minus 1 is plus 3. And plus 3 times 2 is 6. Okay, and we'll go through this again. This time we'll use 3. 3 times 3, or 3 minus 3 is 0, and anything times 0 is 0. So we have 0. Let's use 4. And we get 4 minus 3 and 4 minus 5, which is 1 times minus 1 times 2. So that's minus 1 times 1 is minus 1, times 2 is minus 2. And repeating again, this time using the 5. 5 minus 3 is 2. Oh, but 5 minus 5 is 0. 0 times anything is 0. Okay, and we'll go again. This time with 6. This is going to be 3, and that's going to be 1. 3 times 1 is 3, times 2 is 6. Okay, so now, like we did before, we could now look at this and notice that this seems to be the point that things go up by here and up by there. So this may be the vertex. Okay, so now what we're going to do is just go ahead and graph these points, which I went and did on Desmos. You'll notice a couple of things about this graph. One is that the vertex is where we suspected it was, at 4, 2, or 4 minus 2. And that when we plug in a 5, we get 0, which makes this fall on the y-axis, or on the x-axis. And we plug in a 3, we get 0 here. And that makes the whole thing 0, so we fall on the x-axis there. And so these numbers, 3 and 5, seem to indicate the x-intercepts. Now, you'll also notice that the axis of symmetry is right there on the vertex, and that falls perfectly in the center between the two x-intercepts. So to find the axis of symmetry, and likewise the x value of the vertex, which we can shorten as just xv, you add the two x-intercepts together, and you find the middle between them. Remember back to the last unit where we found the midpoints, that's all you have to do. So this becomes 3 plus 5 divided by 2. Remember, it's not talking about minus 3 because we're looking at the actual x-intercept. Okay? Okay, so the x-intercept is positive 3, and the other x-intercept is plus 5. So we get 8 over 2, which is 4. And that's the x value of the vertex. Now, if you want to find the y value of the vertex, well, an x value is just an input. Plug in the x value into the equation and get the corresponding output, which is a y value. So we get 2 times 4 minus 3 times 4 minus 5, which is equal to 2 times 1 times minus 1, which equals minus 2. And you'll notice that is the y value of the vertex. So now if you just imagine yourself having found the vertex first from knowing the x and y, or the two x-intercepts, then these 3 points are usually enough to draw a nice smooth curve. And you don't even need the step pattern. However, let's take a look at that step pattern. This suggests it may be 2. Let's just take a look. So if we go right 1, okay, so if we go right 1, that would be over to here from the vertex. We go up 2, we do go up 2. Because we're going from minus 2 back to 0, it goes up 2. So this is still the step pattern. Okay, let's try another one, okay? So if we want to graph this one, we could go about the whole thing that we did before, which is create a table of values from knowing that this is just an input-output machine, write in all the inputs, all the outputs, then plot the points. That's completely possible. It will work every time. However, why don't we just use what we see here, which is we have x-intercepts. So I'm going to put them in. Now remember, this is not the x-intercept. Plus 3 is not the x-intercept. The x-intercept is whatever number you have to put in for x to make this piece 0. So in this case, the first x-intercept would be equal to minus 3. The second x-intercept, okay, would be equal to minus 1. So let's put those in. There's the one at minus 1, and there's the one at minus 3. Okay, now let's try to figure out what the vertex is. So the vertex will help us graph. And if we have the x values of the x-intercepts, we divide them by 2 and we add them up, we get the x value of the vertex. So minus 3 minus 1 over 2 is minus 4 over 2, which is minus 2. Now we can just use this information and plug it in to the input-output machine to tell us what the corresponding output is for the x value of the vertex. So this is going to be y equals 1/2, or minus 1/2, times minus 2 plus 3. Now, I'm sorry if this is a little small. Minus 2 plus 1, which is equal to minus 1/2. And this is going to end up being plus 1 times minus 1, which will end up being minus 1/2 times minus 1, which is positive 1/2. So if we go over to minus 2, right there, and we go up just 1/2 instead of 1, that's the vertex right there. Now, the only problem I have with this is that it's difficult to see the shape past that because these points are so close together. So I picked this specifically so that we can show where we need the step pattern still. So the old step pattern 1, 3, 5, new step pattern 1/2, 1.5, 2.5. Okay, so we've already got the half covered. Go right 1, down 1/2. Now we're going to go right 1, down 1.5. So 1.5 would be right there. Then we're going to go again. Right 1, down 2.5. Should take us to there. Now you can see the shape unveiling itself to us a little better. Okay, so we have the axis of symmetry here, x equals -2. And then we can just draw a nice smooth parabola through this whole thing. And there you go. That's how you graph using factored form. So in summary, these give you the x-intercepts. This is still our open up and down and step pattern indicator. And the final thing is, it's just a quick watch out. Okay? If you have y equals 2x minus 7x plus 3, the x-intercepts are 7 and -3. Okay, for the reasons we discussed before, just that's something to watch out for. It's a very common mistake to make them -7 and +3, when in fact it's 7 and -3, because the 7 is what makes this piece 0, and the -3 is what makes this piece 0.